This section is about the divided brain. And but before I get into the divided brain, I'm just going to go back one slide and talk about a term that is just kind of thrown in there somewhere, but it's a term that comes up a lot and probably should have an idea of what it's about. And that's this term called plasticity. Okay, plasticity. And basically what we've learned about the brain when it becomes injured, and this really depends on the type of injury and the location of the injury. This is not necessarily that true throughout the entire brain. But the brain has shown the ability to take, for example, language that's primarily in the left hemisphere, and when damage occurs to the left hemisphere, or even in some cases the left hemisphere is completely removed, language then kind of picks up in the right hemisphere. So some language centers will develop in the other hemisphere. So the brain kind of has this ability. So if you think about it, I guess it makes some kind of sense since we're just talking about neurons. But it's basically, the difficulty is you think about when our brain is developing as infants, and certain neural networks are responding to the environment, and then you take away those networks because of some brain disorder or brain injury. It's going to take quite a bit of time and repetition to redevelop those skills or learn information all over again. That's really essentially what you're doing. But at least when you're an infant, all of that is developing all at the same time, instead of, if it happens as an adult, you're dealing with a mature brain. All right? So that's plasticity. But this video is mostly about the divided brain, and this idea that the hemispheres, the right and left hemispheres, have specific tasks that they're good at. And as you see here on this slide, the left hemisphere processes reading, writing, speaking. So we've already talked about language and how much the left hemisphere is language, but also math and comprehension skills, comprehension from reading, comprehension from listening. And it's really the kind of math skills that are more sequential. The more spatial kinds of math skills are more on the right brain. But you see, in the 1960s, it was termed as the dominant brain. And if you think about our school culture, for example, is really creates individuals, or not only creates individuals, but also caters to individuals who have left brain skills. Okay, so in the 1960s it was termed the dominant brain. That's because that's how our society operated. And if you fell outside of those skills, you weren't catered to. Well, even today, that's probably holds true. All right, art and music are not core subjects for everybody. Okay, but I think I would argue that they should be. So, how do we figure this out? How do we figure out that, each hemisphere has specific tasks? Well, in some ways, we found out the same way we found out how any part of the brain worked, and that's through some of the injuries and diseases and disorders and things like that, traumas that occurred to different parts of the brain, and different things would happen. But then, through a series of operations called split brain operations, and then the test that came about on those patients who essentially had their brain split into two, we found out that each hemisphere had pretty specific kinds of kinds of abilities. So first thing we're going to take a look at is another brain structure that we haven't talked about yet, but is important to know, and that's the corpus callosum. And it's depicted very well here on this cross section, and looks a little different here from the top view. Okay, so this is the structure. It's a very, you can just see by its coloring, it's a very dense structure, density in terms of the number of neurons that exist here. And what the purpose of the corpus callosum is to take information from the left hemisphere and bring it over to the right, okay, and vice versa. All right, so it's a way for two sides of the brain to communicate with each other, and this happens so quickly. It's not like we really even notice it. Now, in split brain patients, okay, and you might ask, all right, why in the world would you ever want to do this? The most common answer to that is epilepsy, severe epilepsy. And the procedure's gotten a bit more refined over the years, but so now we've gone from trying to determine which side of the brain the epileptic seizures begin, and then it was severed, and then the theory is that the seizure would not be able to cross the corpus callosum, and therefore the seizure would not go to the other side of the body, and it works. Patients have fewer seizures, and the seizures they do have, if they have any, are they're not as severe. I recently saw a video of a woman who had electrodes implanted in her brain, trying to figure out where the seizure would start, and as a result, they were able to remove just a specific part of the brain. Now, they thought maybe it was near or part of the hippocampus, and they thought that she might suffer some memory loss, but seemed to turn out okay. So now they're trying to pinpoint where does seizures begin in any particular patient, and just remove that part of the brain and not sever the corpus callosum. Okay, but this is still done. In fact, I've seen cases where teenagers with severe epilepsy, in the most kind of extreme cases, have had an entire hemisphere removed, hemispherectomy. So they have their whole, in this case that I'm thinking about, had the entire left hemisphere removed. And because of plasticity, the right hemisphere picked up some of those language skills. So this is what we see in someone whose corpus callosum has been cut. Anything in the left visual field, okay, goes to the right brain. Anything in the right visual field goes to the left brain. Okay, so that's how to understand it. Kind of simplify it. I mean, technically, what's happening here when we say that, we can't say everything in the left eye goes to the right hemisphere and everything in the right eye goes to the left hemisphere, because each of our eyes has two visual fields, and you can see here that on this left eye, when it's looking at the right visual field, it sends information here in blue to the left hemisphere, and the right eye also sends information from the right visual field to the left hemisphere. Right, so the eye kind of splits the visual fields. But to understand it more simply, left visual field goes to right hemisphere, right visual field goes to left hemisphere. Okay. So they created some pretty interesting experiments on these split brain patients, and I actually had the opportunity to meet Michael Gonzaniga in New York City a few years back, and he actually started this split brain research in Rochester. And we only spoke briefly, but it was interesting. I think he's cited in your textbook to meet him. So what they did is, here's a split brain patient, and they had to look straight ahead. So they're having to look at the dot here. So on this patient's left visual field, okay, is looking at the word he, and in the right visual field, the word art. Okay, even though when we look at it, we just see heart. All right, so when you ask, well, okay, so this is before we get to asking the subject what they saw. Right here, we see he is traveling to the right hemisphere, and the word art is traveling to the left hemisphere. All right, so when you ask the patient, what word did you see? Okay, what word did you see? Okay, they say art. Okay, now why did they say art instead of heart or he, for that matter? So art, if you go back here, art went to the left hemisphere. What is the dominant task of the left hemisphere? Language. Okay, so it has a word for the information that was sent to that hemisphere. The word is art, and was able to speak it. Now, if you say, point with your left hand to the word that you saw, they point to the word he. So how do you explain this? Well, left visual field, sorry about that, left visual field goes to the right hemisphere. Okay, so just the he part of the word went to the right hemisphere. Now, the right hemisphere controls the left side of the body, and vice versa. Left hemisphere controls the right side of the body. So the right hemisphere, the only thing that the right hemisphere saw was the word he. The right hand would not be able to point to that word, but remember, the right hemisphere, because it communicates to the left side of the body, the left hand points to he. Okay? So that's a process that you need to be able to explain to somebody. All right? So if you can explain this slide to a friend, you'll be good to go. All right? Now, this is one of Michael Gonzaga's subjects. Okay? And there's video of this on YouTube that you can check out, or you could try this by yourself. With one hand, without looking, okay, draw a circle with one hand and a square with the other, okay, simultaneously. And you'll find that you have, well, do it and you'll find out what happens. All right, this guy right here on this slide has a split brain. All right, he has two separate hemispheres. And guess what? They seem to work independently. And he can draw two distinct shapes at the same time because his hemispheres are working independently. So one, they don't get confused in the information that's traveling back and forth because he has no corpus callosum. All right.